Hey guys, we're going to get started on calculus and parametric equations. That's the third packet from our last unit. Well, one very obvious formula coming up in this section is that we can find the derivative of any parametric curve by just doing the derivative of the y portion divided by the derivative of the x portion, just like we see right here. So take the derivative of y, take the derivative of x, slap them on top of each other and simplify, and you've got yourself a derivative. One thing I don't have in here is we will need the formula for the second derivative of a parametric equation. So I'm going to work that in up here. And I'm going to use an example while I do it that's not already on your sheet. You'll also notice there's some whiteout that's on my sheet that's not on your sheet. I've changed some of the examples. I had my own examples before, but I thought it might be best to go back to the examples from the textbook, just in case you want further clarification, you can see it from a different source. So you can change accordingly as we go. All right, so for this example, where we're going to practice the derivative, we're just going to use up here, I'm going to fill it in. We'll use x of t is sine of x. This is also from your textbook. We'll use y of t is cosine of x. So I'm including another example that was not already there. We're just going to practice taking the derivative and a second derivative of parametric equations. So if we want dy over dx, we would take the derivative of y. We might as well fit that right here. We don't need a lot of room. Derivative of x of t is cosine of t. Derivative of this would be negative sine of t. Simple enough. All right, so we'd have negative sine of t over cosine of t. We did this divided by this because it's y divided by x. And that gives us negative tan of t. Now, if we wanted the second derivative, that would be the derivative of the derivative. This is what's a little bit different. We can't just take the derivative of this with respect to t. Kind of like how in implicit differentiation, there were different rules for when we differentiate y and when we differentiate x. It's kind of the same thing here. What we need to do is take the derivative of this with respect to t. So d dt of dy dx, and divide that by dx of dt. So we'll take this derivative and we'll just throw a dx dt underneath of it. The derivative of tan of t is negative secant squared of t, and dx dt we already have right up here, cosine of t, and we could simplify this, and this would be our second derivative. So notice, the only thing that's a little weird is that for second derivative with parametric, you just throw another dx dt underneath on the bottom. Give me 1 second. We can see this in action. Be very careful here. In that tan box right there, you can see the formula for it. You can take a look at that if you want. All right, so let's get started on our example here. So just one more time, this is the first and this is the second derivative of this up here, not for what we're about to do. But let's go head down here. All right. So